In this video clip, I'm going to introduce the second type of return on investment analysis method, which is the payback period method. So for this type of method, typically we try to evaluate the number of years a project must be operated in order to obtain a rate of return I for a given investment P with an annual income A. So for example, the initial investment for a project is $20 million. A net annual profit, $5 million is expected. For a desired rate of return, 15%, and we need to calculate what is payback period for the project. Basically, how many years we should run this project in order to get this amount of money with a desired rate of return. As usual, for the equation, we try to come up with a way that will give us the least amount of calculation. So for this type of method, of course, we can try to convert everything back to P, or we can use the given P to find A. Either way, that will give us exactly the same amount of calculation. So in this case, you can evaluate which one you would prefer. For me, I would rather use given A to find P. Try to convert everything back to present worth. So for simplicity, I would like to carry the sign into the equation. So if that is disbursement money, we treat it as negative. So for the initial investment, which is negative, and the annual income or the annual profit, which is the $5 million, I treat that as a positive. Given A to find our P, this is the equation we're going to use, which is right over here. Given A to find P, the present worth. This is the equation I'm going to use. One plus I raised to the power of n minus 1 I times 1 plus I to the n power. And we also have a initial investment, which is $20 million. And after we convert everything to the present worth, that should be equal to 0. Right? So now let's plug all the numbers and move this to the other side of the equation. So $20 million equal to, we plug in 15%, which is 1.15 to the n power minus 1, and 0.15 and times 1.15 nth power. And we do not forget this A right over here. A is the annual profit, which is the $5 million. And we can cancel this, divide both sides by 5 million. So here is going to be 4. And also we would like to move this term to this side of the equation. So that will give us 0.6 this times this 0.6 equal to 1.15 n minus 1, 1.15 to the nth power. And this divided by this, 1 minus 1.15 to the nth power. Alright, so this term, we move to the left and this move to the right. So that will give us 1.15 and power equal to 0.4. And 1.15 amp power is going to be equal to this divided by this should be 2.5. And now we just need to take the log. So N basically equal to the log base 1.15 2.5. So N basically equal to, you can use your calculator to calculate this directly. I always like to take the log base 10 2.5 log 1.15. This will give us N equal to approximately 6.6 years. In order to interpret the result, that means we have to operate this project for at least 6.6 years in order to obtain the rate of return 15% given the annual profit. Alright, that's it for this exercise, and I think I'm done with the lecture 7.